Welcome. My name is John Polanski. I'm an assistant professor here at the Kyushu Institute of Technology, so welcome to Kitakyushu, Japan, if this is your first time being here. And what I'd like to do today is give two presentations, both related to the Mission Idea Contest that's now in its third iteration, and it's hosted by UNICEF. And before I start, I have a handout. Some of you have this already, but this pamphlet, this poster describes the second UNICEF Global Meeting, which will be held in November 2014 in Kitakyushu, and the third Mission Idea Contest, which will be held in parallel. So please take one and pass it along. And for those of you who are listening to this remotely or later, you can obtain a copy of this either online or by contacting me directly. So let's get started. The first talk is going to be a general overview of the Mission Idea Contest, both the current contest, number 3, and previous contests. And the second PowerPoint will be a more detailed look at how to prepare and submit to the contest. So quickly, we'll talk about the MIC3, a little bit of background, compare it to previous contests, talk about the process and timeline for submitting. That's something that we'll look at in more detail later. We'll talk about the evaluation criteria, the regional coordinators in seminar. I'm one of the coordinators for Japan, and this is the seminar for Japan. Reasons to join MIC, and then how to prepare the abstract, do reviews with your team, and other calls for proposal. So, overview of MIC3. What we're trying to do here, the objective is to encourage innovative exploitation of small satellites, micro or nano satellites. For the Mission Idea Contest, the requirement is that the satellite design is for a satellite less than 50 kilograms. So micro, nano, we're in that range. But we want innovative exploitation to provide some useful capability, service or data to the global community, if possible. It can be regional as well. Eligibility is very broad. Any individual, group, or company with suitable expertise or enthusiasm. So you can be an expert, well-established, basically at any entity, or you can just have enthusiasm and be relatively inexperienced. That's also okay. And this year there's only one category. I'll talk about the difference between this year and other years, but there's one category, and it's Mission Idea and Satellite Design. So it's a very focused contest. A little bit of background. The MIC was launched in 2010 to encourage this exploitation that we've been describing. And we all know that the small satellite market is growing very drastically. There are projections that it's actually growing by over 20% per year in terms of market activity, growing into the billions of dollars per year, starting from next year. So it's a very vibrant, growing field. And this is an opportunity for anyone who's interested in space to come up with creative ideas and potentially implement them. It could be students, I think most people here are students, or it could be employees or engineers who are well established in industry already. Previously, MIC1, MIC2, and pre-MIC3 were all successfully organized and held in Japan in 2011, 2012, and 2013. And the number of applicants and the number of countries has been growing. We see here MIC1 had 62 applications from 24 countries. MIC2 had 72 applications from 31 countries. Pre-MIC3 was very small, 22 applicants from 15 countries, but anyone who did or didn't submit to pre-MIC3 is eligible to submit to the actual MIC3. So we expect the MIC3 number to be much higher than MIC2. And a quick comparison. The first Mission Idea Contest had a requirement of 2 or more than 2 satellites, in other words, constellations only, and a satellite mass of less than 15 kilograms per satellite. And there was just one category, and that's a mission idea. MIC2 went further. We allowed a satellite mass up to 50 kilograms and reduced the number of satellites to one or more than one. So individual missions or a constellation. And there were two categories. In MIC2, any given team could apply as a mission idea and satellite design, so a very technical document, or a mission idea and business model. In pre-MIC3, the requirement, the physical requirement for the satellite was the same, but teams were asked to either be a user or a developer. And I'll talk more about what's the difference between a user and a developer shortly. But the pre-MIC3 board was then tasked with putting users and developers together. It proved to be a little bit difficult, but it's something that maybe we'll try again in the future. That being said, for MIC3, we're going back to one category, same rules as MIC2, but the category is mission idea and satellite design. In other words, teams are designing their satellites from the perspective of both a user and a developer simultaneously. And we'll just jump right in here to the timeline. So today is April 4th, 2014. And the deadline for the abstract is about May, June, about 2.5, almost 3 months from now. June 27th, 2014. The abstracts will be evaluated by the review team. Probably I anticipate 100 or maybe more than 100 applications, likely each with an abstract. So, a very competitive process. By September 1st, 2014, finalists will be notified. Probably we will have about 10 finalists. That number may change depending on the number of applications and how strong they are, but I would say about 100 applications and maybe 10 finalists. So the top 10% approximately will be selected as finalists. Those finalists will then have until October 15th, 2014 to submit the final paper. The abstract is 5 pages, and the final paper is 12 pages maximum. And we'll talk about those templates in a little bit. Finally, those teams that are selected will be asked to present here in Kitakyushu on November 19th, 2014 at the second UNISEC Global Meeting. And for students in Japan, traveling to Kitakyushu is probably not a big deal. If somebody is listening to this in another country or coming from another country, we're working with UNISEC to provide some travel support and funding for teams that are selected that are commuting from foreign countries. The criteria. So how do you get selected? Well, there are 100 points. For each team that submits, they will get a score out of 100. And there are 2 basic categories. Originality, which is worth 50 points, and feasibility, which is also worth 50 points. And we'll talk about what each segment means and where to put it into the application a little bit later. But originality is basically a new idea. Is it novel? Is it innovative? Does it exist? Has it been tried before? Are we just doing something in a different way? And what is the impact on society? It's good if it's cool, but if it only affects a few people, it doesn't make the impact on society that we're really looking for that's worth more points. From a feasibility standpoint, it's not only technical feasibility of the satellite, basic engineering and physics principles, but it's also considering the operational problems and design that's required to carry out the mission, and the programmatic cost estimates, development schedules, and infrastructure requirements that are necessary to make the project successful. So, the second presentation we'll talk in more detail about each topic and how to arrive at a good, strong application. So just briefly about the regional coordinators and seminars. we have regional offices, or I should say regional coordinators in at least 24, maybe 30 countries throughout the world. I'll show a map of that shortly. For MIC2, there were 24 seminars like this one in 24 different countries. And about 60% of the applicants for MIC2 heard about the Mission Idea Contest through the seminar. In this case, I think most people here know about it, but hopefully when this video is shared online, it reaches more new applicants. And the function of the MIC coordinators, I'm one of them, I'll give my contact info and the contact info for the other co-coordinator in Japan later, but we're here to give advice. And we're also here to consult with the MIC office, UNISEC, and to, if the need arises or if the time comes, to go to the next level. So first we'll help you with your idea. Second, we'll help you with your application. Third, if you're selected or not, if you want to keep working on your project, we can potentially help you approach policymakers or business people or universities in your region that might be interested in continuing work on your project. So this is the network I was talking about. I don't know if this laser pointer will show up on the video, but we're here in Japan, and we have this global network of MIC coordinators. The yellow stars are the MIC coordinators, and the red stars are from the Kansai Leadership Training Program. So these two organizations somewhat are working in parallel. So we have very good coverage throughout the world. So if you're listening to this in a different country, you can certainly reach out to the coordinators in your region or anywhere. Maybe you'd like to partner with someone in Africa or Southeast Asia if your idea may impact that part of the world. And I'll provide a link. I think it's actually coming up here in a few slides, or I'll provide it in the other presentation, a link to all of the regional coordinators. So why to join MIC? Maybe you want to join because you're listening to this, you're curious, but maybe you need to convince your friends or your colleagues, your business partners. Well, number one, it's a good training opportunity for capacity building, especially in developing countries where satellite technology is just taking off. Two, you can potentially obtain very meaningful mission ideas. And it's not just what you think of. Of course, there will be very ingenious, very creative ideas that you think of, but by participating in this, you will have exposure to many, many other ideas that are equally as good or equally as interesting. Number three, this contest could be a catalyst which can actually make an impact in the real world. And one thing that we care about in the application is the cost. So we want a creative mission that is really interesting and really successful, but we also want something that is affordable and technically reachable in the near term. So you can really think like an engineer with a budget for this point. Number four, high visibility for your ideas. So of course this varies for each person depending on what their background is and who they're working for, but they're generally speaking in the media there's very good publicity for creative ideas that deal with spaceflight and satellite design. So we want students and professionals and academia, people in academia, to join this contest. So how to write an abstract. We'll talk about each section later and what should go into each section, but this is just a quick look at those at the different chapters in the abstract. There are 8 chapters, and there's a template that is available on the website. The website I'll put on the last slide. And if you're not sure how to find the abstract, you can email me. If you want help with the abstract, you can email me. But generally speaking, 8 categories. Need. This is like the introduction. So in a few sentences, we want you to describe the fundamental need. What is the problem? It could be humanitarian, it could be business, it could be scientific. For example, this is just from the slide, some countries need timely tsunami warnings, like Japan, possibly, for example, or the Philippines, many places in Southeast Asia. Mission objectives. No more than 5. The mission objectives should be quantitative in nature. So it's not enough to say that people are in danger without adequate warning, and we want to warn them. We want to say how much time is necessary. What is an adequate warning? Is it 10 minutes? Is it 5 minutes? 30 minutes? 30 seconds? And how many people should we reach? What is the objective of the mission? Very, very quantitative. Number 3, concept of operations. So here we want to describe the idea from a overall mission standpoint that includes the satellite, the ground segment, any communication, any launch vehicles that are used, etc., etc. Number 4, key performance parameters. This is very technical in nature. So this probably deals mostly with the payload and what in particular it's designed to do and how you will know if it was or wasn't successful. For example, spatial resolution, if we're doing some visible imaging. Number 5, the space segment description. So this is the satellite itself. It's not enough. Number 3 is going to deal with the mission, ground station, satellite, launch vehicle. This one is just the satellite, or space segment, so it could be your constellation or whatever you put in space. And in this case, as with the other cases, diagrams and some CAD models, they may be simple, are strongly encouraged. Number 6, the orbit or constellation. So at a minimum, there needs to be an orbital description of each satellite, and it may be more complicated if a team is submitting a constellation idea, but this is very important. Some analytical results or computer program like STK that shows the projected ground coverage or user access based on the selected orbit. 7, the implementation plan. This one is very critical. Teams in the past have really missed out on this one. They're a little bit short-sighted, and they have a good idea, they describe the satellite, but they don't see the project from beginning to end meaning the end of operational life. So here we want to make some estimate of the total life cycle cost that includes design, development, assembly, integration, testing, and launch, but also operations and disposal. And we want to consider facilities and infrastructure that are required to do so. And I'll put the number of points up later, but this section basically is worth 20 points, so 20% of the score. Finally, references. This is another problem that I'll talk about later, and that's that a lot of teams don't do the necessary literature review to confirm that their idea is truly novel, truly original. So the reviewers, who will actually be giving you this score out of 100 points? Well, there are eight reviewers as of now. It's possible that the names change before the contest. Probably most people in Japan and other places are familiar with many of these individuals. I won't describe their backgrounds or their names now, but I will make this PDF available so that on your own time, when you're reviewing this, you can look through their background or possibly contact them directly if you'd like. However, that being said, please don't solicit the reviewers for advice about your project. They shouldn't respond, or they just won't respond with any practical advice. The role of the MIC coordinator, like me, is to provide you with advice and guidance. The role of the reviewers is to impartially judge different projects. It may be that some of them also are serving as a coordinator in their region. I'm not 100% sure. But if they are, they will have excused themselves from giving advice for this cycle. And this is some advice from maybe some of these reviewers or reviewers that have helped in the past with MIC1, MIC2, and pre-MIC3. And I'll talk about this more in the second PowerPoint, but literature review is important. There have been too many ideas that have entered the MIC contest that just aren't original, that have been done before or proposed before, and there's just a lack of research. Could be through the internet, through journals. Probably most students have a mechanism for searching the literature, so please do so. Number two, we understand and we want applicants who don't have considerable space experience. We don't want all of our applicants to be experts who have worked on satellite projects for 20 years, but if you have an idea, we really want you to confirm the basic feasibility of your ideas. If you're proposing an orbit that just isn't possible, or if your structure simply wouldn't withstand launch, that's a problem. So one example is Understanding Space by Dr. Sellers, who is on the previous slide. And there are many other books out there. If you'd like, email me and I can suggest some other introductory textbooks. And number three, seek an experienced advisor or mentor who can review your ideas, especially at the beginning, to help guide them and shape them, to make sure that it's something that you'd like to spend time and effort doing. So, as I mentioned before, the call for proposal is open. If you go to this website, you can download the template, both for the abstract and the final report, so you know that both of those two are consistent. And like I said before, the abstract is 5 pages maximum, and it's due June 27th, 2014, so about 2.5 months from now. And the online system will be set up later. In the meantime, if you really, if you're finished and you want to submit your abstract early, you can always email it to me, and I'll make sure that it gets uploaded, but otherwise just wait until the online system is set up. And the other dates, these were mentioned previously as well. September 1st, notification of acceptance. October 15th, the final paper is due, and then November 19th here in Kitakyushu, Japan, final presentation. As I mentioned, my name is John, Dr. John Polanski. I'm here at the Kyushu Institute of Technology. This is my email address, john.l.polanski@gmail.com. And I'm one of 2 coordinators in Japan. The other coordinator, who some of you may know, is Professor Shirasaka, who is at Keio University, and his email is here, shirasaka@sdm.keio.ac.jp. All other regional coordinators can be found at this URL. You can see it on the screen, or you can get it off the PDF when I send it out. So if you're a different region, or if you want to join a team that's in another area of the world, if you have a good idea that overlaps, please contact the regional coordinator in that region, and that person will help you find a team to work with, or at least give you someplace to go. And you can always contact me if you don't have any luck. If you'd like to speak to the MIC office directly, or contact them directly, send an email here, or call this number. And again, this is the website where all this information can be found.